I know that I'm basically the last thing between you and the party, so kudos for being there, and I hope you will bear with me. I'm Alex. I've been a mobile apps developer for the past 8 years at a company called Flutter Apps, previously known as BAM. We rebranded recently, and I've always been passionate about performance. So I want to start us off today with a question. And the question is, how do you know if your app has good performance? If you Google that question, you will find a video by Google, actually, telling you that your app should run at 60 FPS, 60 frames per second. For example, if you have a feed and you're scrolling in your app, basically your app is like a movie. It's animated pictures. It's responsible for drawing images of your feed moving up, to give you a good impression of fluid and smooth scrolling. And so 60 FPS was a high enough number for a good perceived smoothness, but nowadays we even have devices going to 90 or 120 FPS. So the question is, what does this mean for Flutter apps? So let me give you a quick, really simplified version of what's happening under the hood. So we got something called the Flutter UI thread. It's responsible for running your Dart code and also the Flutter code beneath you. It's going to output something called a layer tree, essentially all the information about size and positioning of widgets, and it's going to send that to the raster thread. And the raster thread, well, its role is to rasterize. But if you're like me and you think rasterize is kind of a big word, to be honest, the thing that you need to remember essentially is that it takes the layer tree, all the sizing and position of the widgets, and translates that into pixel buffer, pixel information so that the GPU can actually display pixels on the screen. And so for your app to run at 60 FPS, all of this needs to run under 16.6666666, etc. milliseconds, because, well, 1 second divided by 60 is 16.666 milliseconds. So this has one crucial implication. Above all, you should not run expensive calculation on your main Dart thread. For example, this is a really stupid app, very simple app with a square fading in and out. But I also have a button called Kill UI Thread, which runs an expensive operation. When you click it, the animation stops. And when the calculation actually stops, so we click it, animation stops, and it's not only we get the not until we get the result that the animation can resume again. All right, so I've coded a really dummy app. It's a feed of guinea pig's picture from Unsplash, because I think guinea pigs are just really cute and adorable, especially on a big screen like that. And yeah, you know, trying it out in the iPhone simulator, I think it's kind of nice. It has good performance, it's kind of okay. So I'm thinking, you know, let's release it, right? Well, wrong, of course, for multiple reasons. The first one is this. First of all, I'm running that on an iPhone simulator, which runs on my MacBook, so it's not even representative of the performance of real iPhone devices. And the second, reason is this. Of course, there can actually be a massive difference between average iOS phones and average Android phones. A website called Geekbench actually benchmarks the performance of devices, and the result of that is actually the most sold iPhone in the world in 2022 can run your Dart code 10 times faster than the most sold Android phone in 2022, which is insane. So you really have to take into account low-end devices. All right, another reason is this. Well, you should not measure performance in debug, you should measure in production or profilable, because debug mode is not representative of your performance in production. And if you focus too much on performance in debug mode, you might actually be fixing issues that don't actually appear in production. And I wish I could say this never happened to me, but, well, cry. All right, so I've promised some live code. What better way to end the day? And so let's do it. So I have my phone with me, which is a Samsung A10s, so quite low end. And yeah, let's see how the how the app looks like. So I've run it in profilable mode from VS Code. And yeah, if I scroll, it feels like, it's working. Maybe it's kind of tricky to see on the big screen, but it's kind of sluggish. Like, it definitely doesn't run at 60 FPS. So let's see what the DevTools have to say about this. To open the DevTools, you get this button here, or you can open it with Command-Shift-P if you're using VS Code. So if I click here, this is what will happen. I will see a bunch of stuff here. Massive histogram, full of bars. And essentially, each couple of bars corresponds to one frame in your app. So for example, if I scroll, I see some new couple of bars appearing because my app is drawing frames. If I don't do anything, then I don't see anything appearing because my app is not rendering anything. If I have, an animation constantly rendering frames because, something's happening, then I can see that, a lot is happening, a lot of bars appearing. All right. So each couple of bars, each couple of bars, the left one corresponds to the UI thread timings, and the right one corresponds to the raster thread timings. So both those timings need to be under 16.6666 milliseconds. You can see actually the bar here at 17 milliseconds, just as an approximation. But yeah, the bar is really, might be tricky to see, but it should really tell you that you should not go above this value. So yeah, you might be guessing that we're not doing that great. And actually, the blue color means that everything is good. And the orange or reddish kind of brown color should tell you that it's not good. You're above your budget of 16.6 milliseconds. So a few issues can happen. So one of those issues is this, which I'm going to choose to ignore for the purpose of this talk. You see a message here about shader compilation jank. And essentially, this is being fixed by the Flutter team moving from Skia to Impaler. So this could be a whole talk in itself, so I'm just going to ignore those issues here. But let's check the other stuff that we can check. So going back to the likes tab, which is just an empty dummy tab, and I'm just rebuilding the tabs every time I click on them, so it's just easier to see. So we can see, for example, that here we have a massive UI thread, the UI thread is taking 198 milliseconds, which is 10 times more than our budget. So what I want to do here is go directly, so I click on it, and I want to go to the timeline events because this is so powerful. But it can be a bit daunting if you've never seen it. I'm going to collapse this. And it might be a bit hard to see at the back, I guess, but I hope you'll bear with me. So lots of colors, so a bit daunting, I think, but it's really powerful. So here we can see everything that's happening under the hood in our app, which is crazy. I can see the UI thread, and I can see what's happening in the UI thread. The top thing here, essentially, it's a function called vsync process callback. It tells me that there's a function called vsync process callback that was called, taking, here I can see the duration 200 milliseconds on the UI thread, so way too much. Vsync process callback is basically your device telling your app, hey, I'm refreshing the screen because I'm running at 60 FPS. Do you need to draw a frame? And then it's calling a function called animator begin frame, and then it's calling build layout in paint. Essentially, what needs to happen for your UI thread to compute what's necessary to draw a frame. And actually, the build part is really what you control directly because it's really the build function coming from your widgets. So here we see that, the build function is actually taking 94 milliseconds, which is way too high. So we need to investigate what's happening. But we don't have a lot of details here to know, what is causing this. So one way to do that is to go here to add more details and track widget builds. So you might be wondering why this is not activated by default, and it actually tells you. It tells you that frame times may be negatively affected. I found that if you try this on low-end devices, they're always going to be negatively affected, meaning that your performance will be worse when you analyze your performance tracking widget builds. Something to take in mind, like your performance measures and analysis can actually impact the performance of your app. All right, so let's do this, and let's try again to see what this gives us. Going back to photos, and yeah, you can see that it's, I think, probably even higher than before. All right, so now in the timeline events, we see a lot more details. We can see that, by the way, in all those kind of tools, you can always like move around with the WASD key, but also with trackpad if that's easier. But we can see here our build function, but now we get more details. We know that our top widget being built is a widget called Future Builder, which then builds its children called Photo List, and then its children called Single Child Scroll View, and then a column, and then in this column we have so many widgets. Essentially, it seems like we have a lot of occurrences of photo list items, something like 50 to be precise. And so you can imagine why our app is actually taking a lot of time to build this. Because essentially what's going on is we're taking a response from the API and we're displaying a full scrollable view of all those items, even if they're not rendered on the screen. So there's one simple solution to fix this. Of course, let's check our photo list widget. We have a single child scroll view, which is building everything. And we can replace that, I have a snippet for that, with a list view builder instead. So that with the list view builder, it's actually going to virtualize and build only the widgets that are appearing on the screen. So let's rebuild, still in profilable mode, and let's see what this gives us. So this is the annoying part about doing performance measures. You have to rebuild in profilable mode, which is kind of annoying, but luckily, I prepared some slides to pass the time. This is the first issue that we've seen. You don't want to see something like this if you go in the timeline. You don't want to see so many widgets being built because, of course, it's going to be taxing for the phone, especially low-end devices. So the good rule of thumb is essentially you should build as few elements as possible. It's as simple as that. That means that if you have lists of scrollable views, you should use listView.builder as much as possible to virtualize your list. And you should, for example, also ensure your tabs are lazy loaded. And essentially, you should follow best practices that are encouraged by Flutter, which I think does it well for a lot of use cases. All right, so now our app is rebuilt. So let's see what this gives us. If we track widget build again, going back to the Lights tab, I'm just going to clear that, and going back to the Photos tab. Okay, so it's much better now because it used to take 200 milliseconds and now it takes 23 milliseconds. And it's a bit higher than 17 because I'm tracking widget build still. But if we check the timeline events for this, and it zoomed a bit weird. I'm just going to zoom in. Yeah, we can see that now build is actually building only 3 photo list items. Essentially, what needs to be, on the screen, and a bit more so that if we scroll fast, there is no blank happening. So this is much better. And the good thing about list builder is that it's supposed to be rebuilding items on the fly when we scroll. So whenever I'm scrolling, I should find that it's going to build the next photo list item that comes into view and basically mount the photo list items that are not into view anymore. So let's double check this. If I scroll, I should, I see a lot of orange actually happening there, and that's not a good color in that context. I hope there's not any Neverlands fan in the room, but in this context, orange means bad. If I click on one frame, let's see what's going on. All right, so it seems that, here we have a build function. Let me just collapse this. We have a build function happening on that frame, and it seems to be rebuilding the photos feed screen, which seems to be rebuilding essentially the photo list and the list view and everything. We can actually scroll to the right to move to the next frame and see what's going on. It seems actually to be redoing the same thing. And the same thing on the next frame, and the same thing on the next frame. So it feels like we're basically rebuilding the full photos feed screen widget on every frame when we're scrolling, which is really crazy, and we should not do that. So let's see what's going on in the photos feed screen. All right, so the photos feed screen is a stateful widget. So yeah, we might take a wild guess and try to check calls to set state to see what's going on. So here we do have one call to set state, and it's happening on the listener on scroll controller, because we added a listener here to see on the bottom. Yeah, if you check on the bottom right of the screen, there's a scroll to top button appearing when we've scrolled past 100 pixels. So top of the screen is not appearing, and then it appears. And if I click on it, poof, I scroll to the top. And so what we're doing is we're showing it conditionally, but what's happening is because of our scroll listener, we're setting the state on every frame, and we're rebuilding the whole photos feed screen widget. All right, so one way to prevent this would be to do something like this. Instead of setting the state all the time, I could compute the new value of my Boolean, compare it with the old value, and make sure that I set state only if needed. And to be honest, that would be a good enough fix. But there's still an issue when I'm actually displaying the button, because you might be wondering, yeah, whenever I'm going to be displaying that button, the one frame I'm going to do that when it's scrolling, I'm still going to rebuild the whole photos feed screen because I'm doing a set state in the photos feed screen. And it doesn't really need to, right? Because I'm only changing the state of the button, essentially. So a better way to fix this would be to actually take a look at my floating action button and extract it into its own widget, which will manage its own state. I have a snippet for that as well, but essentially it looks a bit like this. It's doing the same exact logic as we've seen in the screen. And so I can just now replace my floating action button by my new widget called scroll to top button. And Copilot is back. Pass it the scroll controller as before, and we can basically get rid of our scroll listener here. And we don't need to set the state anymore. We don't even need this, and we don't even need the dispose function anymore. So now if we're rebuilding, it should be much better. So the lesson here is, we had photos feed screen rebuilding on every frame because of a weird set state. The lesson here is that we should really confine data updates to where it's needed. Here was a simple set state, but it can be with something else. If you're using Riverpod or Block, we should really confine state updates to rebuild widgets, only the widgets which need it. And essentially, it's easier to do when you follow the single responsibility principle. For example, here we had a bit too much logic in our feed screen, and so we moved that to its own widget, and it was much better out of the box. I actually find that good architecture goes hand in hand with a good performance. All right, so let's see the result. Let's go back to the Flutter frames again. And now if I scroll, it should be much better, a lot more blue on the UI thread side of things. All right, but you might be realizing that, we still have a lot of massive red bars on the raster thread. And it's time to investigate what those are about. So if I click on one of those and go to timeline events, I can now start to investigate the raster thread instead. So the raster thread is harder to investigate because here we see low-level functions being called, like GPU rasterizer draw, rasterizer do draw to surfaces, etc. And it doesn't give us a lot of insights about what we did wrong. We know that basically this is heavy usage because of our code, but we don't really know what in our code actually triggered that. But there's the IO thread, which runs background operations, which can give us sometimes a bit of hints. For example, here it's calling a function called upload raster image, which actually takes a big time. Yeah, it's running for 383 milliseconds. So you might have guessed that we probably have a problem with our images, and if you have a heavy raster thread images, one of the culprits you might want to take a look at is images. So one easy way to check that would be, for example, to check the network page on the DevTools. So if I go back on the Likes tab and go to the Photos tab again, I should be able to see HTTP requests made to the images, and so we can check if something is wrong with them. So let's check the response, and we can see that we have a very cute picture of guinea pigs, but we can also see that the size reported is 1 megabyte, and the resolution is about 10 megapixels, which is way too high for this app. So we need to change this. So let's go to our photo list item. And instead of taking directly the picture that the API returns to us, we need to tweak it a little bit and get our API to this is this one, yes. Our API to actually, so here this is the Unsplash API, so we can pass a query parm called W and request a different size. So here we're going to be requesting the size of the container, here just for simplicity, the full width of the device, multiplied, very important, by the pixel ratio of your device instead. And so if we rebuild the app, it should be much better. So essentially, this is the third issue. Images can have a massive impact on our app. So we saw that they can trigger a massive usage on the raster thread, but also on the IO thread. You can spot them in the network tab, for example, because yeah, you see the size and resolution. And the rule of thumb here is that you should keep images small. Small disk size is important, but never forget about resolution as well. Because images have a memory impact about the number of pixels multiplied by 4 for usual PNG images. So if you have a 10 megapixel image, it's going to take 40 megabytes in memory, which is crazy. So the adequate resolution is really the size of your container, but multiplied by your pixel ratio of the device. Otherwise, it's not going to look good. It's going to look a bit blurry and not as good as then maybe you're going to have, I don't know, native developers coming to you and say, oh, your images look blurry. It's because, you know, Flutter is not a good solution or whatever. Yeah, that happens. But no, yeah, use the proper resolution. Use resolution over image assets, either coming from the backend or even for local assets. You should have multiple resolutions for multiple devices. All right. So yeah, this should be much better, but I've been ignoring this first issue for a while. Well, I've been ignoring the shader compilation jank, so yeah, I'm gonna close this. But there's still something massive happening at the start of our app. We see that we have a lot of jank on the raster thread when we load the Photos tab. So here again, we can click one of the frames. And if we zoom in on the raster thread, again, yeah, bunch of low-level functions, which doesn't necessarily give us a lot of insight. But something interesting is happening here, very small. If we zoom a lot, we can see that we have calls to canvas save layer. And we basically have 1, 2, 3, 4, 5, 6. So if you've checked the Flutter documentation about performance, it tells you that you should avoid calling save layer too many times. But I'm like, I'm not calling save layer myself. I'm not calling it in my code. So where could it be coming from? Well, actually, there are several widgets, Flutter widgets, that will call save layer on your behalf. For example, clipping widgets, for example, shader widgets. And so you might be guessing that, yeah, this is probably about our skeleton component, which applies kind of a nice shimmering effect that I almost copy-pasted from the Flutter documentation, actually. So if we check skeleton, the Dart, we can see that essentially it's a combination of 6 shader masks, each being applied to one of the items. So for example, just a square for the photos and circle and title at in the beginning for the profile header placeholder. And so those 6 shader masks actually corresponds to our 6 save layers calls. So one easy fix is actually just to regroup them into one single shader mask instead, and doing something like this. So yeah, custom shader mask under the hood, use the shader mask widget from Flutter. So if we do this and we rebuild, it should be much better. So here, this is our 4th issue. We notice some heavy raster thread. So one culprit could be images, but we fixed that already. So another culprit is to check for save layers. And if you have some of those, what you want to do is you have to minimize expensive rendering operations, widgets such as shader mask, color filter, and clipping, which can look really good, but as much as possible, don't necessarily overuse them. So yeah, the result should be much better on the raster thread. So let's check that out. Flutter frames. Yeah, we can see that at the beginning we have a lot more blue. We still have some issues due to shader compilation, but overall, this is much better. There's still one other issue that I want to talk about, and it's kind of hard to see in this view of the DevTools. And it's actually hard to spot on the naked eye unless I change the colors here of the grader. And since we're in Germany and there's a match happening on Friday, I think, let's use some appropriate colors and rebuild to see what it gives us. So when I did this the first time, I was not sure what it was going to look like. The result is quite promising, I promise you. If it's rebuilding, there you go. Right. Beautiful colors. Go Germany. And yeah, okay, so if you're really good, you might be able to spot the issue. Did you notice the placeholder, the animation is shimmering, but it's stopping just before displaying the full screen of images? Stops. Yeah. Let's do it again. It stops. It freezes. So if you remember one of my first slides, you probably would guess that, yeah, we probably blocked the UI thread, and this is why the animation cannot go on. And it's freezing, essentially, the way we see. So this will not really show on the frame view in the performance tools, but you can open instead the CPU profiler page, which would give you a bit more information. Here I can go back to the likes tab, hit record, go back to the photos tab. We see the problem again. If I click stop, it's essentially going to tell me everything that's happening on the UI thread, which is really good. So we have a bunch of cool, interesting tabs, but I want to move directly to the CPU flame chart because it looks a bit more like what we're seeing in the timeline before, and we're kind of accustomed to that now. So yeah, it gives you a flame chart, so essentially broken down version of all the functions that are happening under the hood, calling one another with timings. In orange is basically all the functions coming from our code, and in blue and purple-ish, functions from the Dart framework and the Flutter framework. So here we have all, well, I don't have a function called all in my code, but I'm assuming that this is basically Flutter running everything. And we can see here that we have a function called fetch photos, which takes 2.4 seconds. And you might be thinking, well, yeah, it's a fetch, so probably there's asynchronous work going on. Actually, no, because you see that fetch photos is calling parse response, which calls 2.4 seconds. So the CPU profiler only displays synchronous operation and actual calculation being made. The delay for HTTP request would not appear there. So we have a problem in the parse response function, which in turn is called JSON decode for 2 seconds, and photo API response, well, something coming from freeze to decode the object, essentially, yeah. So what's going on is, yeah, you might have guessed it, we have a big JSON, we're decoding it and parsing it into Dart classes, and we're doing that on the main thread, and so it's expensive and it's blocking the thread. Remember, our budget was 16 milliseconds, and here it's taking 2 seconds, so that's way too high. I have to admit that the JSON I took was really big, just that it was easy to spot the issue on the naked eye. But even with smaller JSON, yeah, it will probably block the UI thread. So the best solution for that is to, yeah, here we see our fetch photos, it's doing the API calls, and we can essentially offload that work from the UI thread to another thread so that it runs in parallel. And Flutter makes it really easy to do that because I can just do final photos equal await. It's so easy that I don't even have a snippet for that. Compute, well, that's not what I want to do. Parse response, so the function, and then, oops. Okay, I should probably have had a snippet for that. And then, yeah. So very simple. We replace our parse response with await compute. And the thing that it's going to do is really offload that to another thread so that it can run in parallel and not block the UI thread, which is responsible for drawing frames and animations. So here, the lesson is, yeah, we had parse response. I mean, one of our response, I mean, decoding JSON can be kind of long. Remember, our budget is only 16 milliseconds. Too long on the UI thread. So, as I said, above all, do not block the UI thread. So you can offload expensive operations to another thread, or of course, simplify expensive operations. For example, you might want to check computational complexity. If you don't know about O of 1, O of n, O of n log n, those symbols, I encourage you to check the theory about this. It can be really interesting. So if we check again, we can see that the animation is not blocked anymore. And it's much better. So that was the last issue I wanted to talk about, but I still have one thing I want to talk about. So of course, we could have improved even more things, like on the UX perspective, etc., like add cache and everything, but well, that would be an even longer talk. But what I want to talk about is that, yeah, here we had some issues that were kind of easy to spot on the naked eye. It's a dummy app. And in real life scenarios, you might be implementing changes and it might be hard to see if those changes have a good impact on your performance. And the issue is performance measures are not deterministic, which makes it hard to check. And there's no secret sauce, like, if you want to deal with it, you need to essentially run several iterations, maybe average the results as much as possible, keep the same conditions for every measure, and automate the behavior you want to test. But look, this is really annoying and cumbersome, to be honest. So this is why at Theodo we created a tool called Flashlight, which takes a lot of inspiration from Lighthouse on the web. And I want to show you how it works, and I'm going to do a live demo for the first time of the soon-to-be, live demo, yeah, of the soon-to-be released Flashlight version that caters to Flutter apps. The easiest way to use Flashlight is to use the Flashlight measure function. It's a CLI tool that you can install on the call command. And here I can just, so Flashlight measure will open the web view, this web view here. I can just click auto detect, and if I do start measuring, it should, live demo, yeah, okay. It should essentially do a live measure of my app with FPS, CPU usage, and stuff like that. So for example, if I click kill UI thread, I will be able to see that my FPS, of course, is going down. Because, yeah, my device is slow to calculate recursive Fibonacci. I can also see that, yeah, the Flutter UI thread is actually blocked. So this is why the animation is not continuing. But you might be wondering, Alex, you talked to us about determinism. How does this combat determinism? Well, we do have another way to use Flashlight, and it's with a command called Flashlight test. Essentially, you pass the app ID of your app, and you can pass a test command. So it can be an end-to-end test or just a simple here ADB shell command to just start the app. What it's going to do is going to repeat the test a few times, by default 10, but here I've specified only 3 because otherwise it would take too long. And it's going to take measures here for 10 seconds. So it does several iterations of your automated reproducible test. It measures performance while doing so, and it takes the measures for 10 seconds. At the end of it, it's going to output all of those measures in a big JSON file that you can open with the common Flashlight report. But the good thing about this is if you have, yeah, there you go. If you have, for example, let's say that I had run the exact same test at the beginning of this session when the app was still in a bad mode, I would have had a bad.json result. So I can do Flashlight report bad JSON, good JSON to compare the result of before the fixes and after the fixes. And then if I click this, I can open kind of the same view as before, but with the comparison view. And here, Flashlight is essentially telling me, yeah, good job. You went from 35 out of 100 to 97 out of 100. So kudos to us. We can see that, yeah, FPS has massively increased. Total CPU usage has massively decreased, especially on the UI thread, but we can also check other thread, for example, the IO thread. Since we're not decoding images, heavy images like before, it's much better. And on the raster thread, we can also see that because of our changes on our skeleton placeholder, it's much better than before. We can even check RAM usage, and since we're not using crazy heavy images, of course, our RAM usage is much better. So going back to the slide, this is basically, yeah, Flashlight, the end of the talk. But yeah, this is Flashlight, which gives you automated measures. It also works in production. You can measure production apps even if it's not your app. You don't have to install anything in your app. And it also doesn't affect your performance measures. It's built to be very, not impact your performance measure. And it can also run in CI with Flashlight Cloud. So that's the end of the talk. I hope that the Flutter DevTools, you will appreciate and enjoy using them now. So Flashlight is actually open source. This is the QR code to link to the GitHub repository. If you like it, feel free to drop a star. That's it for me. Thank you for following up to this point. And yeah, party now, I guess.